Find the maximum or minimum of a quadratic function. So remember that a downward quadratic function had a negative a value in front of the x squared. So when a is negative, the parabola is going to open down, and so you're going to have a peak. You're going to have an apex here. So this will be your maximum where it touches the y-axis. And then when our graph is opening upward, a was positive. The value in front of x squared was positive. So the parabola is opening up, and you are going to have a minimum where the vertex would connect to the y-axis. So this would be your minimum. So when I look at my function, I have g of x equals 3x squared minus 18x plus 25. A is positive. So right now, automatically, I know my graph is opening upward. And so in my mind, I'm going to be thinking about the upward graph, and that I'm going to have a minimum. So I'm going to choose minimum. So where does the minimum or maximum value occur? Well, that is the vertex. So minimum or maximum is going to be y value of the vertex. Okay. So two methods to find the y value of the vertex. If it was in that vertex form, you would have h and k. Or you are going to find the vertex by finding x, by finding the axis of symmetry. Find the axis of symmetry. And remember, x in standard form is the opposite of b over 2a. So we'll go ahead and start with that. So again, a in this problem is 3, and b in this problem is negative 18. So we want to have the opposite of negative 18 divided by 2 times a. Okay. So now we have opposite of negative 18, positive 18, divided by 2 times 3, which is 6. And so we're going to get 3. So x here equals 3. And what is the function's minimum or maximum value? So that's asking for the y value of the vertex. So I want to know where the y value of the vertex is. So we're being asked to find the maximum or minimum of a quadratic function. So what we're being asked to do is decide, do we have a peak or do we have a valley? So again, we have two types of parabolas. We have a downward parabola, where when the a value was negative, the value in front of x squared was negative, our parabola opened upside down. Our U shape was upside down, and it goes towards negative infinity for the y values. So what we have is, when we find this vertex here, it connects to when it connects to the y-axis, that will be considered our maximum, because that's the highest value that we can have. So that'll be our max. Then we had parabolas that open upward, and those are all our positive a values. For positive a value functions, something like this. And you can see that there's a valley created, and at that turning point where it connects with the y-axis, that will be your minimum value. So when we look at the function, g of x equals 3x squared minus 18x plus 25, we notice that a is 3. So a is positive, so we know we're going to have an upward. A is positive, so we're going to have an upward-looking parabola. So in our mind, we're visualizing this type of parabola. It's got an a value of 3, so it's going to be a pretty skinny parabola since it's being stretched by a value of 3. And so we know we're going to have a minimum function, minimum in our function. Where does that minimum occur? Well, that minimum occurs on the axis of symmetry. So it occurs on this line, because all parabolas have a place where they fold in half, and that happens at the vertex, and that value is what the x is. So where does it occur? It occurs at the axis of symmetry. for all parabolas. So depending on your form, if you had vertex form, you would use h and k, and you would use the h value for your x. Otherwise, for standard form, which is what we're looking at here, ax squared plus bx plus c, we're going to be using the axis of symmetry formula. X equals the opposite of b over 2a. So we go to our equation. So we need b. B in this problem is negative 18. So to find x, we're going to take the opposite of negative 18, because it's the opposite of b. And then we're going to divide by 2a, so 2 times 3. So we're going to go ahead and opposite of negative 18 is positive 18. 2 times 3 is 6, and so x is 3. What is the function's minimum or maximum value? That is the y value of the vertex. If I want the y value of the vertex, I just need to plug in the x value if I'm in standard form. If I'm in vertex form, I can easily see it, but I'm not. So I have to plug in the value. So I'm going to take my function and evaluate it at 3. So now I want to take 3 times 3 squared minus 18 times 3 plus 25. Again, the 3 we're substituting in came from the fact that the axis of symmetry calculated to being a 3. So where the parabola folds in half. So we're going to have 9 times 3, so 27 minus 54 plus 25. 27 minus 54, negative 27 plus 25. So we're going to have negative 2. So does this function have a maximum or minimum? So again, I'm going to analyze the a value. So a is negative 1. And b is negative 10. So with a being negative 1, I imagine my parabola looking something like this, opening downward. Okay. So again, it's just a rough sketch, not exact values, but I just know that my parabola is going to be opening upside down. And so does the function have a minimum or a maximum? So I know that it's opening upside down. So I'm going to have a max. And then what is the function's minimum or maximum value? So it's asking me for my y value again of the vertex. So I need to first find the x, which is that axis of symmetry. So we're going to use our formula, opposite of b over 2a. So x will be the opposite of negative 10 divided by 2 times negative 1. So now we have 10 divided by negative 2, which is negative 5. So actually my parabola should be over here. But again, we were just visualizing a sketch of what it looks like. So now I know that the axis of symmetry is at negative 5. So my parabola is actually somewhere over here. My vertex is a maximum, so it's going to be something like this. It may be lower, but it should just be a sketch. This is a sketch idea of what we've got going on. So now we know the axis of symmetry is negative 5, and we're still being asked to find that y value. So now I'm going to plug it in. So I'm going to take our function, f, and plug in negative 5. And so we want the opposite of negative 5 squared minus 10 times negative 5 minus 29. So now the opposite of 25, again, remember negative 5 squared is negative 5 times negative 5. So that gives us positive 25. And then negative 10 times negative 5 is 50. And then we need to minus 29. So negative 25 plus 50 is 25 minus 29. And we are at negative 4. And again, you can use a calculator to type this math in to calculate, or you can keep your skills, your arithmetic skills fresh, and do the order of operations. So that is how we find the maximum or minimum of a quadratic function. Again, analyze your a value. If it's positive, think of an opening up graph, and you know you have a minimum. If it's a negative a value, then think of a downward looking graph, and you know you have a maximum. And then find the vertex depending on the format you have.